Okay, how's everybody doing? So, as I was saying, today we're going to continue on the main principles of programming. And there's about three or four concepts that is, as a programmer, as an object-oriented programmer, it's very important for you to know. Not only because it's pretty sweet to know, but also whenever you go to an interview, they will ask you these every time. They will ask you this as a package um, question. It's like a canned question. And hopefully you will be able to give them a canned answer, or at least an answer that it's decent. It's not canned. I mean, you'll understand what it is that you're talking about. But it's not something that is like, it's not difficult. Once you learn it, you say like, oh, okay, polymorphism, yeah, this is it. Abstraction, yes, this, yes. But in every interview that you will go to, they will ask you this question. If they don't ask you this question, then it's that's kind of rare, and you probably got lucky or something. I don't know, or they weren't prepared.
It's like the stars interview. You just expect them, and if not, great.
Yeah, yeah. I mean, it depends. Like most of the time, like about 90% of the time, they will ask you this question. So and you're expected sort of to kind of know it and explain it in a decent way. So let's go over the first two that we kind of went over. And again, don't feel too bad if you don't know it 100% and if you don't understand it 100% right off the bat, because these things grow with you. The understanding of each of them grow with you. For example, I mean, you don't understand, and you have encountered polymorphism, but you don't understand the beauty of polymorphism and why it's so strong and why it's so important until you actually start using it. So we will get there. We will get there. And same thing for inheritance. Actually, I dare say you understand and you appreciate inheritance, correct? Um, well, I hope you do. Right? Philip?
Yes.
Yes. Okay.
Yeah.
Yeah. Yeah. All right. Good. 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 Yeah. So main principles. Let's go over the ones that we have already done. Okay. Inheritance. Okay. Dan, what's inheritance? And tell me why it's good, and give me an example or something.
So using our spellcaster and the character template, we'll have our character template, and other classes can inherit from that template, um, whatever the qualities are, and then they can have their own qualities on top of that.
Beautiful. Beautiful. Yeah. So you inherit, or you basically can get to use all the properties and methods and functions of that class. So in a way, you are of type of that class, and you can use everything pretty much. So for example, if you were of type cop, um, then you would be able, to like maybe get a cop car or get a gun or have a cool ID and pull people over or something. You know what I mean, right? Yeah. So
Yeah.
that class, you get all the cool shit that that class has. So if you were to get inherit something of type Rambo, if you were Rambo, then you could use bazookas and some cool shit. And then, but you would have that, but you could still do the cool shit that you do, right? I think a good example on inheritance is, um, all right, let's say, Dave, let's say you inherit, the movie Predator, right?
Yes.
Okay, you inherit the Predator class. What can you do?
Uh, Infrared vision
Yes, what else?
tracking.
Beautiful, beautiful. Okay, that is nice. That is nice. All right, so then, um, but then you could still do stuff that you yourself can too, right? Okay. So what about? Do you guys see the alien? Right. So there was an alien. Well, I mean, there was a predator that inherited an alien because they're kind of morphed into each other, right? They
The Pred alien.
Yeah, the pred alien, right? So if you have a pred alien, he can do stuff from, he's an alien, but he's also a predator.
And that's also a good example of our polymorphism there.
Yes, that's where we're going. That is the kind of where we're going. That is where we're leading. So polymorphism. Um, Dave, give me the main, the main idea of polymorphism. What is it?
The ability for a class to have many different types of class
Yeah,
as well as its own type.
yeah. So it has the ability to be different types, to be itself, and to be other classes that it may have inherited. Short, simple. It can be itself or other classes, so it can be different types. That was very nice. Yeah, that was good. And like I just said, so for example, if you have the dude, you have the predator alien, then he can be both. He's a predator and he's an alien. So let's say if you have a ship and it needs one of those like weird DNA tests, right, to go into the ship, and it only allows predators, then he could go in, right? Because why? Because he's part predator. And let's say that the mother alien was around, right? And it's killing everybody except aliens because she can smell them. Then the alien predator would sort of survive, right? Because why?
Or alien.
Exactly. So it can use polymorphism is that it allows it allows a type or a class to be of different types at the same time or whenever you want. There is such a thing where you can sort of filter what what part of a class you want. For example, hey, do you only want the predator class? Then you could sort of have a filter. Imagine, think about a DNA filter or something like that, or some kind of like portal or something. That so for that, for an amount of time, you could just use the predator, the predator side, or the alien side. Excuse me. Is that somewhat clear? Maybe. Yes. Yeah. I mean,
Yeah.
yeah. You guys get that, right? It's not that bad. It's pretty straightforward. Once we start using it, that is when I think you guys will say, "Oh, okay, so this is um, why we're doing this, and this is why it's good." Okay, so now, okay, so guess I'll leave that there. Okay, so let's move on to the next one. The next one would be in no particular order. Let's call it, I guess data encapsulation. Sure. All right. Yeah, actually, let's just call it data hiding or something like that. All right.
Are those like kind of ways to describe the same thing?
Yes. Mhm. It's abstraction. It's sort of the same thing. I'm just gonna rename it. He's just calling it, or they're just calling it something different. Okay, the next idea is called abstraction. Okay, abstraction. Okay, so what does it mean to you? I don't know if you've heard it before.
It's basically taking a line of code and making it like, uh, I want to say ambiguous, so that it could be used in different ways. You don't have to rewrite your code every single time. You just use this one piece of code that kind of sort of is a catch-all for certain things.
Yes and no. This is a little bit different than what you're talking about, but I see what you're saying, though. I see what you're saying. This is a different concept. Well, it's you're sort of right because the abstraction can mean sort of that's why we're kind of trying to define it here, like what we want it to mean. But you're correct. You're correct in a way. But for object-oriented programming, and what this will mean most of the time is the ability. Okay, we are engineers, right? We're engineers. We're architects. Are you guys with that? Yes.
Yes.
Okay, we are architects, and it's kind of important for you to think of it that way when thinking um, of C sharp and these and the main principles. Whenever you think of these, you are coming from a place where you are a builder, you are an architect, and you're creating something. And the something that you are creating, you wanted to follow certain rules. And if these rules are followed, then your product or your house or whatever you're building should be cool or should be okay, or at least should have a decent chance of being okay. It doesn't mean it's a, it's perfect or anything, but these are things that help you make your house or whatever you're building better. These are some ideas. These are concepts. Okay, so again, that is the main thing, that when dealing with these, you are an architect and you are creating something. Okay. Um, Now, as object-oriented programmers, which really, I should have really driven this more. I should have drilled this and nailed you guys a lot more on it. But this is a question. It's okay if you cannot answer. You probably can, because, I mean, you know it. You know the answer. But as programmers, as C sharp architects, as C sharp programmers, we build stuff. But what is the main building block that we use? What is the one thing that we always using, that we're building, that we make, that we create? Of course, it's code, but what unit, what is something that we're always building and making and messing around with? Yeah, I really should have done this from the beginning, I think. But you'll get it. Well, go ahead. Any ideas? Just throw out words, random words that we know and we have used. Anybody? Go ahead. You got 15 seconds. 7 seconds. It is a very easy answer. Yeah, I think don't overcomplicate it. What's the one thing we're always using
Convention.
and making? Well, yeah. Well, what's the thing we're always creating, always making?
Something in memory,
Well, yes.
a storage or something.
No, but you guys are close. Well, what is the basic building block of everything we do in programming and object-oriented programming? Well, I am saying in object-oriented. Yes, exactly. So, and what objects do we use? What is the main object that we use?
Class.
Yes, there you go. Oh, yes. Um, it's a class. Look at that. Let's check this out. This is the one thing I really should have driven home and kind of drilled you guys and banged you over the head with. Um, but class is the number one important construct that we have learned, that we're learning. Everything you do in an object-oriented programming, or pretty much 99% of the thing when you deal with object-oriented programming, is something of type class. Do you guys see that? You see we created a class here, right?
Yes.
But also notice that if you scroll up, what is this? The controller that we're using, what is it? It's a class, right?
Yes.
And that inherits another class. And this inherits another class. I don't think you could go into the home controller, I think.
Okay, scale.
Let's see. Go to definition. There you go. This is a class here. And then the class another goes to another class, controller base, and so on and so forth. So pretty much everything that you deal with in an object-oriented environment is a class. And classes are the building blocks of programming, object-oriented programming, which is what we're doing. Which is why when you see the database, when we Entity Framework creates classes, right, of things that we have on the database, right, of the tables in the database, so we can use them, interact with them, right? You guys see that? And the classes have properties and some have methods, and but again, it's still a class. So again, as an architect, as a programmer or an architect, the building blocks that we use are classes. And they have things like properties and methods that we use to do all sorts of cool things. For example, the character class, we gave it these properties and we gave it these methods, which allows it to do things. So when we created this object here, so all classes are pretty much objects. We could just call them that, object. It's an object. That's why it's object-oriented programming, because everything you create, it's an object. Pretty much, yeah, most of the things. That's how you interact with the code. By treating things, as objects, being real world or being an idea. Okay. Is that better? Or are you guys good with that?
Yes.
Okay, so yeah, let's see. Main building block is a class. Alright, object. Beautiful. So when you're creating these building blocks, or when you're using them, you expect them to be in a certain way. If I were to build a car, for example, right? Okay, a car is pretty cool, right? But if I were to describe, like, I use a car, right? To me, a car, all it is just I get in, it's a wheel, and it has two pedals, and I turn it on and I go. If I press one of them, if I press the left one, it stops or slows down, and if I press the right one, it goes faster. Okay. That's what a car is to me, pretty much, because I don't know a lot about cars, and that's really all I need to know about a car. Yeah, it needs to be, so whoever designed the car class, right? When they created it, let's say that we have some kind of let's see, wait, hold on. Yeah, so when we have the car, whoever created it with with somebody using it in mind. And when you create something, do you want it to make it easy? Do you want to make it easy, or do you want to make it complicated?
Generally, it's good to be easy. Sometimes complication is hard to get away from.
That is right. That is right. Yeah, so you want it easier. You definitely want it easier. Let's see. Hold on. And yeah, so whoever created it wants to make it, you as an architect, you want to make it as easy to use as possible. So you don't want to burden the user with a lot of unnecessary information and a lot of unnecessary levers and buttons and stuff. So if I were to create a car and I wanted to sell it to a lot of people, I would create a car that is just, hey, you get in, you press a button to turn it on, and then you turn the wheel and you press two pedals, and then you're good to go. Okay. Um, let's say that you design a car, but you could choose to put a whole bunch of pedals in it and like buttons and well, you guys know what manual is, right? Like a manual transmission, like where you use the stick.
Yes.
Yeah. Yeah, so if you had a choice, I mean, well, not you. I mean, on average, which person, um, on average, which car would most people choose? You think?
Which car? What?
Automatic.
Well, automatic
Automatic.
or stick. Yeah, most people would choose automatic over stick, correct?
That depends on if they have to maintain them.
Well, no, I know, but yeah, on
But
average,
yes,
yeah,
driving on automatic is much easier.
yeah, and it's less of a pain in the butt and everything. But yeah, so that kind of, but you do understand that at one time, they had the automatic and everything, and that to use the automatic, you need to do more. So you need to provide a lot more information and interact more with that class than the what is the automatic one. Sorry, I'm in the manual. Yeah. Okay. Yeah. So good. So we have a choice there. Okay. What about a car that I'm just leading you guys. We're going somewhere. Don't worry about it. Okay. What about a car that in order for it to work, you needed to know how all the parts work, and if you didn't, it didn't work. Would that be a good car, you think, for the average person, for most people? I know you guys are probably good with cars. I'm not. I hate cars. I mean, I don't know a lot about them. I'm afraid of them.
It takes a lot of effort to know that much about cars. Yeah, it's probably not great for everybody.
It's not. It's not. And so it's kind of a pain. So it's not a very good car, a car that you have to kind of interact with everything, and know how everything works in order for you to use it, like the spark plug, whatever belts, and whatever turnover an engine or something like that, or I don't know. So yeah, so the inner workings. Um, that would be a kind of a crappy car if you had to do that to know. I mean, for the average person, remember we're talking about the average person. It wouldn't be a very good car. But if you compare that to the current car where you just says like, hey man, get in, boom, we got two pedals, we got a wheel, we got a button here, boom, and then we can go. Slow down, go faster, easy peasy, beautiful. So that's a good car. So when creating the car, the concept of the car or the car itself, um, who you think is a better architect if they're making a car that would make it easiest for people to interact with a car, actually use a car for the average user? Would it be somebody who'd like a modern automatic car, or a car that you would need to know intimate things about the car? I
This is a
mean,
user
yeah, yeah,
experience question. The better engineer is the one that makes it easier for the user.
yeah,
So
exactly.
the automatic, hands down.
Yeah, it's not even a question. I mean, it's pretty straightforward. But you guys understand, yeah, that so when we're creating, so from now let's hop over to programming. And remember, you guys are engineers. You guys are gods. You guys are creating the building blocks of whatever you're creating. Whether or not, depending on the domain, if you're creating a game, or you're creating a car, or you're creating bank entities, pretty much anything. It is up to you to make it as easier to interact with of or as hard. Okay, so now that is the concept of abstraction. Okay, so in this case, what abstraction means is, hey, only show the user what he needs to know, what he needs to know or what he needs to use. Don't give him anything else, right? Keep it simple. So what it means is, show the user or give access yeah, to the user on only on the basic things or what he needs, only what he needs to know, right? And then this is where it comes in. Are you guys ready?
Listening.
Hide the rest. Boom. That's right. Now you got to tell me, hey man, how do you hide the rest? That is a good question. You hide the rest, or you just hide the stuff by not showing it to them. I know that that seems a little bit weird, but basically, what we mean by that is when you create a when we're
Totally.
I'm sorry, what?
It totally makes sense. There's
Oh,
a
it
reason
does?
why we have a hide or show hidden files check mark in Windows.
Exactly.
Because that stuff most people don't even want to touch. It's system files we shouldn't touch.
Yeah, you don't need that. You don't need that. You know, and not only do you not want them to see, but you don't want them to see the inner workings of your stuff. Sometimes you have information in there that you don't want them uh,
Yeah.
to see, like maybe some kind of IDs or bank account numbers or social securities or all sorts of stuff that you don't want them to know. You just want them to have access to things that you think they can use. All right, so let's expand on this and let's get it to a solid state here. Okay, so what it is, so it's show access, yeah, give access to the user. I don't know, abilities or let's see, only. Actually, yeah, give access to the user only what they need. Yeah, let's keep it simple. I like this. This is good. And then hide the rest. So, yeah, so give access to the user only what they need, and then hide the rest. Um, and this is something, like I said, that as an architect, as a programmer, is something that you will be doing yourself and you will be getting better and you will be evolving. And understanding and this is something that the understanding for this is something you also develop over time. How it, how you can create better classes by eliminating things that you don't need to show them or functionalities that you don't need to show them. Let me see. Yeah, only what they need. Actually, I should really say functionality also. Yeah, only. Let's see, only the functionality they need. That is sweet. So let's go on the net and see what people say about abstraction or something. Let's see if it matches to what we have been doing here. So this guy calls it data hiding. It's most of the time it is abstraction, but this guy is just data hiding, I guess, right here. So yeah, refers to the ability to hide concepts of programs and code that are not required or the user won't interact with. Um, and that is pretty much what we just said, correct? Let's do a quick search. I mean, that's what we do, right? C# object oriented programming, and let's go. What are we looking for? Abstraction? Yeah, abstraction. All right, Stackify. What is abstraction? All right. Through the process of abstraction, a programmer hides all but the relevant data about an object in order to reduce complexity and increase efficiency. That is another way of saying what we just said, correct? And again, remember, these are just concepts that we're learning now and that we will use and develop as we go. Right now, we are not doing, like, we're really not going to go all out and be, let me phrase this correctly. Okay. Inherently, on the stuff that we're working on right now, we are doing it correctly because what we're working on is simple objects. So you are sort of already doing it by default because we're kind of coming up with, things, some of the properties, and we're only using the functions that we need. So most of the time, we're pretty we are gonna be we're kind of sticking to excuse me, we're kind of sticking to that principle anyway. But it is something that you should always have in the back of your mind because you want to sort of follow. You want to, what is it? Keep it simple, stupid, right? Is that what it is? What is it? What is that anagram? Is it an anagram? Yeah. Kiss.
Kiss.
Yeah, yeah, yeah. There you go. Keep it. Oh, yeah. Keep it simple, stupid. There you go. Yeah, and again, I'm not gonna harp too much on this, but excuse me. But yeah, I mean, just do what you can, show what you can, and then just keep it, hide whatever you don't need to. It's again on the stuff that we're working on. It's pretty straightforward. We don't need to. But when you're dealing with certain things like huge classes and you're designing certain classes, just keep it simple. That is the main thing that you need to remember. Don't show them stuff that they don't need to know. For example, in our class here, right? Um, let's see. Yeah, there's stuff that they might not need to know. They need to know all of this, right? But there's other stuff that they might not need to know, like what's the dude's mom's name or something, or like where did he come from, or what is his weakness or whatever. But again, we are doing it by default because the objects that we're dealing with are not that difficult. But again, always remember, you guys understand what abstraction is. It's just, hey, show them what they need to know, functionality they need, hide the rest, and keep it simple. Does that sort of make sense to you guys? Are you guys with it?
Yeah.
All right. So no questions. Let's see. All right. So now on to the next one, encapsulation. All right. Well, give me an idea of what you think that. Well, what does it mean to you? Give me a little something. Let's go with Dave this time.
Encapsulation.
Yes.
I think it means something that you put inside a capsule, right?
Yeah, yeah, that is correct. Yeah, that is legit.
We've already kind of sort of been doing this a little bit.
Well, yeah, we have. All right. Okay. Dan, is that the same for you? Kind of your answer too, sort of.
Pretty much, yeah.
Yeah, yeah.
We use like the public and private terms to tell our code whether it can be shared or if it remains encapsulated with its own children and inheritance.
Yeah, that makes sense. That makes sense. I dig it. I dig it. But remember these principles. I mean, you are correct. But we need to define it as when it comes to the principles as an architect, right? Remember, we are architects here. Shablips. So we think, well, think like one. Does that make sense? I guess. Yes. At least when using these principles, right? Um, and and these are kind of important. These are really important because I remember. Let me go on a tangent here for a second. I remember I had an interview for a job once, and the guy he asked me questions about like these like hard not hardcore questions, but because normally once you get up to a certain level, you don't really bother with these things, right? At least for me, because you kind of assume like these principles, right? But he gave me an exam and told he asked me to design some classes, like an architect, and I did it fine. But he like nitpick on like the smallest things just because I did not observe it 100% and because I was not thinking like an architect 100%. And that was really weird. That was really really weird. But it's always important to keep in mind that you're an architect. You are creating classes. You're programming. It's not going to come in that much, but it will. But it's kind of important. And again, this is something that we're just going to be doing automatically, and it becomes kind of we do it by default. But anyway, encapsulation. So what encapsulation is, whenever you create a code, make sure it's self-containing. Okay, so piece of code. Remember, this is kind of like the definition from a architect point of view. I mean, you were correct, but this is kind of like looking at it from a different way. So piece of code that is self-containing. Sufficient. Okay, so and these are concepts as well. So piece of code that is self-containing and self-sufficient, so that it can plug in or connect with other pieces of code. So kind of like a module, right? So if I say something like module mentality or module like, module mentality, like a module, I guess. That's kind of what it is. So we have been doing that somewhat, like when we created our class, right? Our character template. Is it self-containing and self-sufficient?
Generally speaking, yes.
Yes, yeah, exactly. Oh, I like that. Generally speaking, yes. Yes, generally speaking, yeah, it is. We can use it. We can package it, and somebody else can use it, and it'd be cool, and we can use it, and it's pretty sweet. Does it need anything else to work? Not really. It is uncoupled. Oh, that's another word.
Yeah, that's a good one.
That's a sweet word. Shit, yeah. Should I just bring this down here? I guess, right? Yeah. Piece of code that is shit. Did I lose it? Maybe. Where'd the code go? Damn it! Give me 1 second, I guess. I guess it's gone. What the fudge? Yeah, fuck it. Hold on.
Control Z a bit and see if you can find it again.
Yeah, I guess. Oh, I guess it was here. Okay, let's just rewrite it. Fuck it. Let's do it live. I'm just gonna close this down here. Okay, so piece of code that is self-containing. What was that other word that I used after that? Damn it. Well, self-containing. So all logic is encapsulated in the class. Doesn't need anything else to work. And what was that last thing that I wanted to add, which was good? I forget here.
I lost it too.
Yeah. Oh man, we both lost it. Dave, do you remember?
What, it is uncoupled?
Oh god damn it, Dave.
Yeah.
That's right. Yes. Uncoupled. Yes. Uncoupled from other classes. Yeah. So don't need anything. Don't need no man. Don't need no other classes to make it whole. Okay. Let's see. Oh yeah, so I mean, does that make sense? Have we been doing that so far? Let me see. Let's see. I mean, have we been doing that so far? Do you guys think we have been able to do that, or we've been doing it kind of by default? Let's see. What do you guys think? Are you guys there? Okay.
Yes. We
Still
are.
here.
Okay, yeah. I mean, we kind of have, right? Let's see. Yeah, sorry, I was responding to a text. All right, yeah. So encapsulation, it doesn't need anyone. It's self-containing, and that's what we're kind of doing, and that's what it is. I mean, that's what the concept is. And let's look for it. Let's see. So what should I look for? C#, programming. Is it object-oriented programming? Encapsulation. Okay, yeah. It's defined as the process of enclosing one or more items within a physical or logical package. Encapsulation is an object-oriented programming methodology prevents access to implementation details. Yes. So, what it is, yeah, right here.
That's a much better description than what I found. That was very to the point.
Oh, which one? This guy here?
Yeah.
Yeah, it is. It's like the process is enclosing one or more items within a physical package. That's what it is. And so together with this, right, like encapsulation. So the cool thing about this is that encapsulation and abstraction work together. Because one tells you keep it simple, stupid, right? And the other one tells you keep it simple, stupid in a tight package, right? Let me see. So in a tight.
The other one tells you sealed with a kiss.
Yeah, exactly. Oh, yeah. I'm gonna use that too. Sealed with a kiss.
Whack.
Right there. So keep it keep it simple. Keep it simple and tight. Yeah, so simple and tight in a package. Actually, let me add in a package. Let's see. All right. Features and object-oriented programming. Yep. Yeah. So I mean, I'm trying to. I mean, they're not hard concepts. They really aren't. I don't want to spend too much time on it if we don't need to, because um, yeah, I mean, abstraction is just keep it simple, and encapsulation is in a package. So the whole thing is, keep it simple and tight in a package, and sealed with a kiss in a tight package. And these are things that you have to be aware of as we go on. But it's something that you evolve with. This is knowledge that you evolve with. These two is something that you know and kind of understand right off the bat. Right? I mean, we looked at inheritance. Boom, we know what inheritance is, and we can use it. Same thing with polymorphism. I mean, we haven't really used polymorphism that much, but we understand what the concept is, and we're able to do all sort of cool things with it.
Polymorphism and inheritance seem to be pretty closely related.
Exactly, yes. They are tightly knit, yes. Basically, once you have one, then you kind of automatically have the other, which is really nice. Yeah, and these two. So yeah, so these two are tightly coupled. They go together. Inheritance and polymorphism. Should I do like a cool underground thingy? Yeah, there you go. Yes. Whatever this called. Yeah. So these two go together, and these two go together as well. And these two are more solid ideas, somewhat, I guess. And these two are more abstract. Just when you design shit, try to keep it simple and try to keep it together. That's all it says. Should I even, yeah, over here? Yeah. Let me write that down just so, let's do it. Yeah, so yeah, when you design stuff, keep it simple and together. You gotta repeat it a few times there, just so it's cool. Okay. And okay, so let me ask you a question. Okay. All right, Dan. Give me 4 main principal ideas of object-oriented programming. What are they?
The ones we just talked about?
Yeah. What are they called?
Inheritance, polymorphism, encapsulation, and
I always forget that one too.
I don't know why I'm blanking.
No, I blank it too. Don't worry about it. All right, Dave. What are they?
Polymorphism, inheritance, abstraction, and encapsulation.
All right, abstraction. We forgot abstraction.
That's why.
Yes.
I blanked out on it because it was too abstract.
Exactly. Yeah. That's a good way of remembering it too. Yeah. So abstraction. So there they are, and yeah, I mean they're there. We're gonna be using them, and we're gonna be growing with them. Then not only are we gonna be growing with them, but they are gonna be growing with us. Like their meaning and their use. Ooh, I like that. I'm gonna put that in an outtake or something. That was pretty sweet. Okay, so yeah, so you guys get this. Should we spend any more time on this, or should we move on? What do you think? Are you guys with it?
I'm pretty comfortable with it. I'd be happy to move.
Yeah. Well, I mean, also when we do that, we're gonna be. I mean, also remember that we're always going to be using these principles. It's not like we look at them now and then we stop. We're always gonna be. Always gonna be using them, and once in a while we're gonna stop and ask ourselves, hey, how do we feel about what we have created, and how do the principles apply? Did what we create, was it encapsulated? Was it simple? Was I able to make it use other things that already exist, so I don't have to create double the work? So these are things that we will always be asking ourselves as programmers and architects. And that's kind of important. 1 second. All right.
I got that going on too.
Was that? Sorry.
You got a thing going on outside? Texting?
Yeah. Sorry, I'm back.
No worries.
Okay, so now I'm back. So next. So we feel comfortable with these. We have the 4 basic ideas, well, main principles of programming, and we feel legit. Okay. How would you feel if I asked you to create a project that had a base class, and from that base class, you had to create other classes that build on top of that class?
I think I understand what you're saying. Like, we'd have the base class, and we'd have, say, 4 other classes that had some properties that they'd use from that base, but they'd have their own things as well.
Exactly. That's exactly what I said. And this is good because from now on, I will describe things, and it's up to you guys to figure out what I said or try to say it. Or, requirements are weird, and people are weird when they give requirements. So the better you get at it, listening what people want, the better you're off, I think. Dave, did you get that also when I said?
Yes.
Okay, yes. So that's important. Okay. Yeah. So we have. And what if I ask you to interact those objects with the database as well? Will you be able to do that? Like save information from the database and and retrieve it. Okay. I'm letting you guys off the hook for now. I will ask you to do this, by the way, but I'm just accepting yeses for now. Once we set up these bad boys, then I will not be accepting yeses. I will be accepting actual homeworks and actual assignments, because you will be expected to finish them and work in order nonetheless. Isn't that cool? It is cool.
Yeah.
Hey,
you heard about what happened with Git, right?
Oh yes, that is crazy.
It's
Um,
kind of, I guess, good for us.
it is very good for us. Yes. What happened was that, remember that we were talking about source control, version control. Let's call it source control. Actually, is a much better word. Source control. Okay. One of the biggest, well, source control is the storage for code. So let's say, let's talk about source control. Yeah. Let's say that you guys, like, we're a team. We're a team. Well, let's not say we are a team. We're a programming team, and we're working on a project. Okay. So far, so good. Yes. We need a place where we can centralize our code, so we are updating the same code base. It's called a code base. So let's see. Let's expand on this. Might as well get the knowledge. All right. And that way we start eliminating things on the list of things that we need to do. All right. Okay, so as a team, we need a place to keep our code so that we can get the latest code, update it, and then those changes that we did, upload them to the latest code, and then, basically all the new stuff that we do, we update it, we upload it to the repository, so that has the latest code. And yeah, so basically it's a repository for our code. It's pretty straightforward. One thing that I might be fudging here or not making clear is that, um, well, did that make sense at all? What a code repository is? Yes.
Yeah.
Okay. Dave, yes. Yeah. So
Yes.
yeah. So it's a place. Yeah. Code repository. Yeah. Sometimes I'm not sure if I made myself clear, so I have to ask. Yeah. Let's see. Place where the team keeps their code. Pretty straightforward. Can get latest or historical versions. Well, versions. And update the code. Okay. So let me just go over one more time. So yeah, so let's say we have a code repository, and usually it's on the web somewhere, and we all get the latest. So I go ahead, I add a new page, I make sure my page works and everything, and then I upload it to the repository. Once I upload it to the repository, that means that I have updated the repository. Okay, so now when you guys, right, Dan and Dave, when you guys get the latest, my change is going to be there because you guys are getting the latest. That is pretty easy to get, right, or pretty easy to understand.
So far.
Yeah, and that's pretty much it. That's what a code repository is. It's not hard. Why it's important though is that, or why it's so powerful is that as we commit changes to it and we update our database, it keeps track of all the changes that we have done. So it keeps different versions of our code. So let's say that I fucked up badly and committed something, updated the main source, and I fucked up the code and I did something really bad, right? Then, since it keeps tracks of all the versions and all the updates, we can say, hey, backtrack or roll back to the good version where things were not fucked up. And so that is really powerful. Or just filter out all the bad things that I uploaded. Just take them out of the code. So, I mean, that is kind of powerful, isn't it? Because if you didn't have that, then you will be fucked in a way, right?
It could save a lot of effort. Yeah.
Yeah, yeah. Or what about if somebody gets like pissed off or something, and just deletes like a bunch of code or something from a version? Then, I mean, of course, there's ways to lock certain things so they cannot delete the history version, right? The previous versions, only the ones that they're working on now. So then we could just say, okay, I mean, you fucked up a code, it's fine. I mean, we could just get the old version that we had and that worked, and then we're fine. All right.
Or keep a fork of the code handy.
Yes, yeah.
Privately.
Mm-hmm. Yeah, that's what we do. So they have different kinds of storage systems, code repositories or source control software. The main ones, there's one called SVN. That's just what the name is. It's just Subversion.
What is this?
It's Subversion. That's what it's called. Yep. Yep. Subversion. Let me just look it up here. Subversion. SVN download. There you go. What? Yeah. What is Subversion? Yeah, there you go. A software versioning and revision control system. That's kind of what it is. It's just don't get confused or anything. This is I used to use this one. This is very nice. Tortoise
I
SVN.
use Tortoise. It's pretty good.
Yeah, Tortoise is not. Oh, okay. So if you use Tortoise, that's big. It's very nice. We'll probably be using the building Microsoft one for now, but they're all really good. Yeah. So yeah, if we were to use this, um, this would be a way of of keeping our code on a server somewhere that we'll find, and then we could get versions, get latest, and keep our short, our 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 code safe. Another one is called GitHub or Git, which it's really it's very popular. Uh, yeah, it's called. If you go to GitHub here, built for developers. Yeah, so pretty much if we created a branch, I mean, if we created an account here, we could just give me the latest code. Here, it's like basically it's a server where we can keep our code, and they keep track of it, and we can update and all get the same code. So it's pretty cool. It's very cool. And Microsoft is about to buy them for a lot of money. Like a lot of money. I was like, Jesus Christ, that's fucking crazy. It's like, what is it, 62 billion? That's a lot of money. It's like
Crazy.
you could buy a couple of things with that, I think. Yeah. Yeah, so a lot of businesses keep their codes here. Like, what is it, PayPal, Bloomberg, Walmart. So Node. Yeah, so a lot of companies and a lot of businesses keep their code base here or code, and they keep track of it, which is pretty cool. Yeah, so it's powerful. It's very powerful, very useful. And the other one is called Visual Studio Repository, or just Visual Studio Source Control or Source Safe. It has a bunch of names. Source Safe. I think Visual Studio. Let's call it Visual Studio Source Safe. Here. All right. All right. So there we go. So there is not much to. I mean, you guys understand the concept, right? Okay. I have not set up the repository yet, but I will show you a cool repository. You guys are ready for that? It's gonna be pretty sweet. Let me just show you what our repository looks like. Once we set up our repository, it's gonna be pretty nice. Okay, so let me just log into a project here. Don't worry about it. Ooh, building JavaScript apps with Angular. Man, we need to learn Angular and get paid, my friend. Get paid. Angular is pretty good shit. You know, you could just straight up learn Angular and go balls out. But it's a bit tricksy anyway. Okay, so yeah, so let's see. Actually, no, you cannot. You have to couple Angular with C Sharp, which is what we'll be doing anyway. Is not standalone. Okay, so let me show you. So Source Control Explorer, right? Okay, this is what we use at work. Pretty sweet, right? Look at that. So we keep our code here. We have a Visual Studio account. And this is our code here. This is our branches. This is the main code, main branch, and whatnot. And we have so whenever this is our main branch, so whenever we want anything, whenever we update, well, first of all, whenever we want the latest code, we get the latest version here, right? And let's say I make a change, then I update this, I upload it to the cloud pretty much, or to the internet, so other people can see my change. And it keeps track of all these things, which is pretty cool. I mean, again, it's not what we're trying to do right now is just understand the concept. We will, once I set it up through here, then I could go balls out. Well, we could all go balls out and actually using it. I hope you guys are ready, and make sure your brains are ready, because we're going to be setting up some pretty cool things soon, and we're going to be using them. And once we have that, then we'll start doing, getting more hands-on, and you will sort of have to spend some of your time, out of class, messing around with this and doing that, doing those assignments and getting things to work for you. Because we need to both grow as programmers and do assignments and do actual things. We'll do them together, of course, don't get me wrong. But we also have to fulfill our schedule, which is, as you can see, we have a fuck ton of things that we still need to do, at least to do it well. Do you guys agree with that? Do you guys see what we're saying here? Well, basically, we got a lot of shit that we need to do, so make sure you need to win it, pretty much. All right. So far so good here. Yeah, I'm sorry. I'm still kind of hanging over from the weekend is still around, so no worries. It'll get better. Okay, so yeah, so source control. From 1 to 10, how do you feel about source control, and that, well, at least the idea of source control?
The idea, a solid 10.
Ooh, oh damn. Solid 10. Okay. Okay, Dave.
Source control?
Yeah, how do you feel about the concept of source control? Do you understand it?
You meant saving your code
Yeah,
in a place?
pretty much, yeah. What we've been talking about, yeah.
Yeah, probably an 8.
An 8? All right, yeah. So until you see it in actual action, then it'll become a 10, right? But do you understand that there's a place, it's a code repository where we keep our code, pretty much, and we can all access the same code and update the same code base. Is that somewhat clear?
Yes.
All right, great. Let's see. Give me 1 second. Now, let's take a 1 minute break, chilling. Well, I don't go anywhere, but yeah, just give me a minute.
I'll be a minute as well. Take care.
Beautiful.
That time to fill up.
All right, do. I should have brought something to fill up. Damn. All right. All right. I think we're almost back. All right, let's see. Principles of programming. There you go. We can put a sweet check on that. Namespaces. Let's do that. Beautiful.
I'm back.
All right, no worries. Okay, so we are working on going over this list and kind of fulfilling. There you go. So we're going to be working our way, not in any specific order, depending on how many. So we're going to be working on these topics from now on, whenever we can. It's either, I mean, it's going to be a mix of that, doing actual programming, and setting up an environment. Our cloud environment here. So it's going to be a little bit of a hodgepodge, or just depending on how much time we have, certain classes, because some of these, as you can imagine, take a lot more time than others. And that kind of makes sense, right? And some of these might we could probably wait till later or something. I don't know. We'll get there. Okay, so next thing I wanted to go over was namespaces. Okay, so anybody have any idea what a namespace is? Just wondering.
To be honest, only a very vague sense. I know we work with them, but I really don't understand how they interact.
Ah, beautiful, beautiful. Oh, that's good. That's good. Let me see. But that is good. They say. So what we're going to be doing now, it's sort of fill in our knowledge of certain things that we have been using so far, and but we're kind of been taken for granted and just assuming that they're there. But it's sort of important for you to know that it's there and why it's there, correct?
Yeah.
So one thing that we have been messing around with and that we have been doing, it's something called namespaces. Okay, so whenever we go to a class, a home control class, do you guys see the keyword namespace there? You do, right?
Yeah.
Yeah. Whenever you create a class here, this is the namespace, arena fight. And views don't really have a namespace. Only classes do. Namespace. Okay, so what a namespace is, it's a container where you put your code. Okay. Now, the way it works is it's mostly a logical container. Well, it's in a way it's physical like this, yeah, but it's just a container of where you put your code. So when, let's say that we have a namespace, right? Okay, so the base namespace of any project, it's its own basically. You see how we call this this project arena fight? Okay. Then the base namespace for this project is arena fight. Okay, now don't lose me. Don't worry. We'll get there. So all our code that we will compile pretty much will be under arena fight, under that namespace. Okay, so all our classes, methods, and things we create, they're going to be under there. So that then we know where to find them. And well, another reason that we do that is so we can separate it from other projects. So okay, so now this is I think it's going to become a little bit clearer. Let's say that Dave, you have a project, right? Called Arena Fight, and I have a project called Arena Fight. And do you guys remember when we create a project and we actually compile the code, it creates a DLL, it creates an executable? Do you guys remember that?
Yeah.
We will go over it again, but you do remember that it basically it becomes a library of your code. Okay. So if we both have, so basically the namespace becomes a way of differentiating spaces or differentiating where you want to keep your code. All right, sorry, I'm kind of going a bit around with this one. I'll just go straight to the point. Okay, so yeah, so it's a place where you want to keep your code. The reason we have them is that, let's say that you have this character template, right? Okay, so now, and you see how we have controllers? We have arena.controllers. So in this namespace, we're going to keep controllers. Let's say that, right? Let's just say it. Okay, so, and we have something called home controller. But what if I wanted to create something called home controller again? Would I be able to create it under the same namespace?
Absolutely not. I've run into that.
Exactly. You cannot. So that's why you're allowed to put things in different namespaces or different areas. That way the names, they don't conflict with each other. And it's a way for you to kind of create areas for your code where it's like, hey, so, kind of order things, based on however you want. So let's say you have the base namespace, right? But let's say you had a bunch of methods. Then you would want to create all your methods under the methods namespace. So arena.methods. Or pretty much, it's up to you to create it or divide your code however you want. But again, namespace, all it is just a way to divide your code and keep your code in a certain container. The base one being this, but then you could put it under different ones, just in case you don't want to conflict with anyone else's name, or just to make sure that your names are unique. All right. I know that I fumbled around there a little bit, but let's ask the internet for help. Okay, because I'm pretty sure they got something better there. Yeah, my prep today is not that great, but it's all right. We will forgive me. We will forgive us. So what we're looking for is what is a namespace? There you go. .NET Framework uses namespaces to organize its many classes. Yeah, so it's an organization tool. There you go. Okay. Yeah, one thing that I just remembered is, so a namespace is somewhere that you keep your classes in, right? Okay. So it's a way of ordering your classes to keep them in a place, pretty much, or in a place, so to speak. Okay. So now I'm going to ask you a question, and this is where it becomes important, and this is why we use it. So again, it is a way to organize the classes, to keep them all in a certain container or in a certain area. Okay, so far so good. You guys get that, right? Yes.
Yeah.
Okay, so let's use certain namespaces. So, do you guys see in our code? So, when using some of these, right? You see when we're using our controller here, our home controller? Okay, so do you guys see over here where it says using system.web.nvc?
Yeah.
To you, what does that mean?
That's a reference that we a lot of those are stuff that are pre-built, so it's hard to understand unless you're missing it. But yeah, occasionally you'll ask for a class or something that is provided, and you have to tell the system, where you're getting that from.
Well, yes, yeah, but I mean, what I meant was, where, so yeah, I mean, you're correct. You're definitely correct. Yeah. So what this is a namespace. This is the namespace called system.web.nvc.
Okay.
Yes, and in this namespace, what kind of stuff do you think, or would you think, what kind of functionality or what kind of classes are in this namespace?
I mean,
Yeah,
basic
yeah,
web/MVC type stuff.
exactly. Yeah, yeah, exactly. That's exactly what it is. So we're kind of using a library, or we're using classes in that namespace. So in a way, a namespace is where you keep, a certain amount of groupings of classes, or a library, so to speak.
I have a practical question for you.
Yes.
Can you throw in some garbage but working linq statement in there in that code and
Sure.
watch it pop up?
Yes. Oh, okay. Yes, I can. You mean like in our code here?
Yeah,
Oh,
because it's
sure.
grayed out. We're not actually using it.
Most of the time you will, I think, but well, let me see. Sure.
I mean, just
X
as an example.
equals well, crap. I need new list string.
Oh, there you go. System collections generic just
Oh,
popped
okay.
up.
Oh, okay. There we go. Oh, yes. I was gonna get here, but yeah, this is fine. So yeah, so we were not using the generics before, this library before, this namespace before, but since we are using something of class list, guess what happened? Shablips, shabloinks. It popped up, so now we're using something from there. So that is pretty cool. So again, if we were using with something from System Web or LinkQ, then it would pop up if we were using it. So now, and again, of course, as you can see, as you can guess, this type, and under what namespace does it exist? The list type.
It's in the generic collections.
Exactly, yeah. Exactly, yeah. It's in the system.collections.generic namespace, which again, aka, it's kind of like a library, or is the space where these types of functions reside or live.
If we were in a different document and we wanted to call on this file, we'd say using arenafight.controllers. Is that how we would work that?
1 second. Hold on, let me finish this. What was that? Sorry.
If say we were working in a completely different document and we wanted to call the arena fight namespace, we just say using arena fight.controllers.
Yep, pretty much.
Okay.
Yeah, maybe we could test it out. Like, we could go here, maybe. You can even go here. Well, maybe. I don't know. Let me see this. Using. Oh, there you go. Namespace. Arena fight. And then you say dot. And then do you have any other one? Is there? Look at that. Blip. And then we're using that. And then in here, once you have these, then you have access to anything under this namespace, which could be pretty much all controllers if we just keep all controllers in here. And by default, pretty much all controllers that we create are on this namespace. So again, it's kind of a container that you keep all your code in for certain things. It's up to you to name it. If you want, you could just keep everything in the base name, right? The base namespace. But then, excuse me, you would run into the problem of having things with the same name, which you cannot have. Right? Okay.
I'm not sure I follow you.
Was that, sorry?
I'm not sure I'm following either. The base.
Well, you see how here I have a home controller, right?
Mm-hmm.
Okay, so this home controller, under what namespace is it?
Arena fight.
No.
Oh, you mean I guess it's in the system web NVC?
No. What is the namespace? What is it? What is the namespace for this home controller? What is it? Where is it? It's right here.
I thought I said that already.
No, you didn't. You said this.
Arena fight?
It's not arena fight. It's arena fight.controllers.
Okay, gotcha.
Yeah, it is totally different. It is a totally different. It's a totally different namespace. It is something. So yeah, so it's. I mean, it is under the arena fight, right? But it's a different area. It is not the same as arena fight. So if you were to, for example, create a home controller, well, so again, if I were to try to create a home controller in under this namespace, it would not let me. It would say, hey man, there's already something called home controller here. You cannot create another one. But if you were just to create it under arena fight, I mean another document somewhere, then it would let you, because they are under different namespaces. Arena
Gotcha.
fight, yeah. Arena fight is one namespace, and arena fight.controllers is another namespace. They are different namespaces. It's just a way of I don't know, of setting things apart or keeping things in a group. And in which case, the way you're going to be using namespaces most of the time is, hey, what kind of utility, what kind of library do I want to use? Like, what kind of library, what kind of utilities do I want to use? So what kind of namespace are you looking for? Are you looking for the generic? It's like, hey, let's say I wanted to use list. I wanted to use the list type. But in order, well, first of all, right? We know what the list type is because we have used it before. But if I were all willy-nilly and wrote, hey man, I want you to use something of list type, would it work automatically?
You mean if we didn't define it or didn't call it?
Well,
in
I,
references.
well, exactly. If there were no references, if there was nothing, I would just say, hey, man, I want something of list. I want to create something of list. Uh, it would not. It wouldn't. It doesn't know what it is. Because when we have used it before, it's a type that it was defined somewhere, right?
Yeah.
And where is that defined? That type under
In its namespace.
exactly. And that namespace is the system.collections.generic. I mean, yeah. So that is where we could find this function. So namespaces pretty much are another way of saying it's a library. Like so, so it's a library of a collection of calls, a collection of functions that we can use that are kept in a container or some address somewhere. Okay. And of course, the way it's done, I mean, because it's nice, you keep them, for example, system. System is the base system. And then collections, right? And there are many collections. Collections include arrays, collection includes all sorts of things. And we want something more specific. So therefore, include generic. Okay, so um, another question is, hey, what kind of stuff do you think I would find under the namespace or the library or namespace? System.linQ. What do you think?
All those magical linq commands that we
Yes.
don't understand yet.
Not yet. No, soon though. Soon. Yes. And system.web, that is mostly system.web stuff that we're not using, at least not yet. We're using advc stuff, and that's enough for us. Okay. So let's go over and see what kind of um, spaces there are out there, right? And just see. So using system, and then I'm gonna press the dot, right? Let's see what kind of namespaces or libraries there are out there, right? So look at that. We have a namespace for data. We have a namespace for drawing. So this namespace or kind of library, so this is kind of a repository or there's codes in there that I would assume is for drawing shit, right? So it's a library that has functions, methods for drawing, right? Or classes for drawing.
Loosely speaking, yeah, it's mostly like box making and cutting out graphics.
Yeah, pretty much. It's and then let's see what else. We got globalization. Globalization, if you want to do things in different languages like Chinese or Spanish or Japanese or something, this would be a pretty friendly or pretty useful namespace or library. IO, it's for file related stuff. If you want to
Oh,
mess
that's for
around.
files.
Yep, input output.
I was gonna guess like mouse and keyboard and
That
stuff
too.
we'd use for games.
No. Well, yeah, that too. That would be under peripherals probably. But yeah, IO is probably too. There's link queue, management, media, net, reflection, resources, and all that kind of stuff. Text has some pretty powerful things. Threading, timers, web, Windows. But anyway, you guys see. So I want you guys to sort of, in your mind, when we talk about a namespace, think of a type of a library in a kind of a container for code. So that's why, let's say, namespace arenafied is sort of the base namespace or repository or library for your code, because that is where you're keeping it. That makes sense, right?
Yeah.
And also, it's important to have these namespaces because when, let's say, you create a library, right? And I create a library, and we have these functions here, right? we have these methods and actions, and it's important to have them that they're not the same, because if not, they will get confused. They say like, hey man, who are you referring to? Are you referring to the home controller in your code or my code? So then this would be, like my arena fight, and yours would be your arena fight, or something else. So again, it's a way to keep code separate in an area, and to get it, not get it confused with other people's code as well. But that doesn't really happen that much. But the most important thing is treat them as libraries. That's what it is. I mean, that's what they are. Again, let me just take this home. C#, cool namespaces. I don't think there's really any cool namespaces, but but yeah. So namespaces, heavily programming. Okay, yeah. So let's always go out on the web and try to see if we could learn something new. Okay, they're heavily used in two ways. One, it uses namespaces to organize as many classes. So again, we are organizing our classes into the arena fight namespace, or arena fight controller's namespace. It's how we choose to separate our classes. And the other one is when you use it with the word using, you treat it as a library. So you're importing that library into your code so you can use it. You could use the methods and the classes in that namespace. So then you have all the cool stuff. So let's say, if we wanted to do math, right? What kind of namespace would we need to use? Let's see.
Is it system math?
Let's see. We have system.math. I think we have something system.math. And then, I mean, I would assume that in system.math they have a lot of cool math shit, right? Hopefully, maybe, I don't know. But yeah, so it would be it'd be cool to use. All right, and again, they have a lot of cool stuff. So namespaces, one. Let's actually put this. All right, one main one. Let's go back and let's steal that, because I like that right here. Yeah, so .NET Framework uses it to organize classes. Keep it short and simple. That's how we get paid right here. Boom. One. All right. First, .NET Framework uses the namespace to organize as many classes. Boom. We understand that, right? No need. Okay.
Yeah.
Second, although there's a 2 right there, but we'll be jiggy anyway. What is the second one? What is it? Hit me. What is the second main use? Why do we use them, or how do we use them as? Used as libraries. Oh yeah, libraries of classes.
I was gonna say to encapsulate the classes.
Yeah. Ooh, I will use that. Encapsulate classes or group here. Classes, groups of classes. Yeah. Well, that's classes, but yes. Okay. And again, I mean, we're kind of a little bit all over the place today, but yeah, I think these are kind of solid ideas here that we have. This one is, yeah. Okay, so namespaces. How do we feel about namespaces? Do we understand them from 1 to 10?
Probably about a 7 or 8.
Okay.
I feel a lot better about them now, but working with them is gonna
Yeah. Once you get
prove
in
to be a
there,
little interesting.
yeah. No, it's. Remember, you dictate where you want the stuff. You don't have to. You could just put everything into the base namespace. You feel free to do so. But if you want to divide things and make them a little easier for you to understand to find things, then you could extend it and put it into other places as well. It's kind of up to you.
I do like that idea. It's harder to work with as a noob.
No, yes, yeah, I think so. I mean, I do that a lot of the time. I just put everything in the main one. They just do it by convention somewhat, but it's fine. I mean, controllers are expected to be in the dot controllers namespace of the project. And I mean, that is something that is expected somewhat, but you don't have to. Okay, Dave, how do you feel about it from 1 to 10 on that? You good?
Yeah, around the 7.
Around 7, yeah. Yeah, it's yeah, as long as you understand that again, it's a grouping of classes, could be your own or somewhere else, and it's just you could treat it as a library that you're using from somewhere else. Like all these things are libraries. I will go over references later on, but these are DLLs, which are pretty much libraries of code and classes. And you see system here? Do you see system here? So basically you're saying, hey, from this code library, this DLL, you see system DLL here? From this system DLL, I want to use this namespace from here, or this namespace from here. And we'll be going into what these are soon, or yeah, actually pretty soon anyway. All right, I don't want to hit you guys too hard. Okay, so yeah, I mean, take it. Prepare your minds of the onslaught that is going to be coming. I hope you guys are ready. Make your minds ready. I will be finalizing or actually setting this up for us, and I will probably. How do you think it's better that once I set mine up, should we kind of set it up set up yours together? Or should I send you some stuff and you can do your own setup or something? I don't know. Yeah, we'll see.
I like consistency. I think if we all set it up the same, that might reduce
Yeah,
trouble.
yeah, I think so. I think so. It's also better for the video too because then we could all um, get or use the same source, um, which goes a long way. Okay. So yeah, I think we're gonna be done today, and again, hope you guys are ready because we have a list here, and this list needs to be satisfied, and I will be expanding this. So namespaces. Should I put a check in there? Is that check good? You think, or not really?
I'm happy.
Yeah, it's a decent check maybe, and yeah, I think so. All right. But yeah, all right. So yeah, I need to get back, get some rest, and get over the weekend, and then be ready for this week. All right. So we are done for today, and be ready because it's about to get interesting and harder. So yes. All right. All right.
Sounds good.
All right. Later.
Later.
All right. Take it easy. Let's see where we're at over here.